There we go. Now everybody's on the record. I had a couple of interesting parking things the other day. Lady parked next to me and was coming out of that office, and she was actually backing in, and she said she actually was in there and she had to move her car out because she saw on the screen in my car a big red circle that she was being recorded because I have a Tesla and it's Sentry mode. And then this morning, going to a doctor, an SUV pulled into a parking space and a lot of things fell off his car because he was scraping the square post on the right-hand side.
Oopsie.
Yeah.
So that first one, the lady moved her car because she noticed she was being recorded in public?
She thought she was too close to me.
Oh.
And I walked up. I was leaving when I saw her putting her car back in. I said, no problem. I can fold my mirrors.
I've never driven a Tesla.
You're missing an experience.
I wish list for a long time, but I wouldn't be able to charge the batteries in my condo, so I basically need to win the lottery and then buy a regular house with a garage before I got the Tesla. That's probably never going to happen.
Well, there's always supercharging.
Malden or Medford is, or was it Melrose, has put in chargers on the poles for street parking.
There's also a lot of places that have free charging. It's a level 2 charger. But like out here where I live in Framingham, you've got Shoppers World, you've got Natick Mall, all have free chargers.
Yeah, free slow charging at a shopping center encourages you to do a lot of browsing.
Yes. But fast charging, of course, it's Tesla supercharger in Shoppers World. But one thing that's disappointing in Massachusetts is I was looking at level 3 charging for non-Tesla vehicles, and almost all of them are 50 kW. Tesla is generally 150 kW or about 250 kW for the new ones. There are no Electrify America 350 kW chargers in Massachusetts or in New England. I think there's a couple in New England. But if you buy a non-Tesla and you want to take a long road trip, you have to do a little bit of planning.
I find a lot of people have the electric car for commuting and the gas car for long trips.
Some people do. I was going to go out to Iowa, a farm in Iowa, to meet some of my former stick buddies from Vietnam. And my wife forbade me because of COVID. But I could make it out into that farmland in Iowa with no problem. A few years ago, I drove up to Jackman, Maine from Boston. And it's 100 miles north of Augusta. And the Tesla I had at the time had about a 250-mile range max. And so when I got up there, I was a little bit range aware, but I was able to plug it into my cabin overnight. Even though that was slow charging, it gave me about 10 to 20 miles of range that made it more comfortable. But Jackman now has its own Tesla supercharger, and so does Skowhegan. So going up to Jackman today is a piece of cake. No, you don't really have to plan. But with a non-Tesla vehicle, the infrastructure really isn't. It's there, but you have to do a lot of planning. You know, every rest area in the Mass Pike has a CCS charger, but I think they only have one per rest area.
All right, everyone want to start? Let's if I can share. Let's see what sharing looks like on this thing. Oh, okay. I'm going to share the entire screen. That might be fun. Oh, it's only taking one screen. Okay, good. I have multiple screens. So let's start. So there's some people who don't know what ZFS is. Can I have a show of hands in chat? So if you're used to computers, chances are you're used to a boot disk and maybe a separate hard disk for home or something like that. If you're adventurous, you've probably installed CentOS or something and got an LVM that's kind of like a high-powered partition manager. And I didn't do a lot of artwork on this, so this is just a general overview. So if you're familiar with RAID, all right, RAID is a way of taking multiple disks and presenting them as a unified volume, right? But RAID's kind of limited in that it's only for redundancy. I guess there's RAID 0 and all that, but it's fairly limited. So Sun and Sun Microsystems came up with ZFS. And it's sort of like an amalgam of all of the better ideas in storage, right? So ZFS can take multiple disks and form basically a pool. And out of that pool, you can create logical disks or LUNs that look like hard disks. So for instance, on my machine, my system, I use a ZFS Z pool, and I had a whole bunch of LUNs created. These are called ZVols. A ZVol is a Linux device that looks like a disk, feels like a disk, acts like a disk, but it's allocated out of the Z pool. All right. So if you look at are all just various disks that I use for virtual machines in my system. Right. So we've got a CentOS 6 GUI, which goes to ZD16, and you see part 1 and part 2. That's the boot and whatever. So if we look at, I didn't do it on that one. Okay, that's funny. All right. So that's the ZFS ZVols. I'll get into more in a minute. But the idea is to have basically array of, on this system, 6 disks, logs. I'm not going to get into too many details here, because if we want to do an in-depth discussion about ZFS, that could be a long presentation and kind of fun if you want to get into it. But right now we're going to talk about high-level user space usage of it. So it's basically a system that can concatenate and manage multiple disks and allow you to control how it's used, how it's allocated. It helps you replicate. It can take point-in-time snapshots where you can basically say, this data is something I want to save, so you snapshot it, and that'll never change. And you can always have it. So let's go to the first slide. So before we start going down, let's talk about some basic conventions. Disks are these things, right? That's a disk. A LUN is a logical unit that is created by a RAID controller or a storage system that looks like a disk, feels like a disk, but isn't really a disk. You could be familiar with this if you've used LVM and logical volumes. All right, you do LV create the size of your volume, and that's a LUN, right, for convention. A pool, in LVM parlance, that would be a volume group. All right, and so a pool is made up of a number of disks. Right, a volume is a unit of managed storage. It can be a LUN, or it can be a file system. It can be just some logical entity that defines some storage array or some storage space. A volume manager, sorry. This is something like LVM, ZFS, BTRFS. It's an amount of software that can help you manage multiple disks in sort of a sane way, one hopes. Any questions? Nope, I'll continue. All right, so LVM, I'm hoping that a lot of people here have some experience with it. Chances are if you installed CentOS or some of the more modern, or I hate to use modern for CentOS, but if you use some of the more enterprise-ready Linuxes, they tend to use LVM, where they'll put a root file system, LVM volume group, on your boot drive, and then allocate out of it. Right? LVM, they have the PV display, physical volumes. Then you create a volume group, and then out of that volume group, you make logical volumes. Right? With ZFS, it's interesting in that it can do all the things that LVM does. It can create logical volumes. It has a pool, everything. And this is sort of like a very internal sort of distinction, and I don't want to get too far into it, but LVM manages disk space on the disks themselves. So they, generally speaking, when you allocate a logical volume, the logical volume is a fixed entity in a system, and when you write to it, you update it. All right, it's in place. It's very static. You know, you write once, it write when you write to a block, it writes once and it's done. ZFS is different. Couldn't use my mouse. Sorry about that. ZFS is different, and we'll get into this in a second. But ZFS allocates objects out of its pool. It's a lot like the difference between allocating a flat file and doing operations on a flat file versus a database, where your logically contiguous things are scattered all over the place. BTRFS is similar to ZFS, more similar to ZFS than it is LVM. I'm not going to go into it because it's been removed from Red Hat 8. If it becomes like a major thing, then it's something we should talk about at some point. Any questions before I move on? Okay. So ZFS is very interesting in that, unlike LVM, like LVM, it takes all your disks and makes them into a pool. But the pool itself is a file system. So if we want to look at that, we can look at my system. So if we go into, and you can adjust wherever this is mounted. It's a setting in ZFS. So this is my volume, right? These are all just different projects I've worked on. And if you look at what's left, my Z pool here is 17 gig, or is it 17 gig? No, it's 1.7 gig.
df-h.
All right. What was the question?
If you try df-h, you'll get a human readable output.
All right. So it's 1.7 terabytes. All right. So that's just my disks. But you also notice that I have ZFS, home, demo, and volume 1, vol 1. These are objects allocated out of the Z pool, and they exist as objects, and they're very similar, and they have the exact same storage size as the Z pool itself. And in ZFS, when we talk about the pool, we talk about the configuration of the pool. Now this one, kind of pay a little attention because this is kind of important. This is my pool. I have 3 drives in an array configuration. Each of these drives is it might be 2 terabytes. So this should be 4 terabytes with a RAID, right? The log file, that is the slog. Basically, when you write to ZFS, you don't write in place on the file system. Every time you write, you allocate new blocks out of the pool, update the object, and if there are no other users of that block, the previous block is freed. Please remember this, because that's very important in the future. It's not copy on write, it's redirect on, it's like copy on write, but it's redirect on write. Whereas when we write, a new chunk is allocated and inserted into the object. And the old chunk, if it has no further references, will be reused. But it could have further references. And we'll get to that in a minute. The cache is just basically a cache. The logs is a write-ahead log that allows ZFS to update the metadata securely so you don't lose data. Now, what can we take out of the ZFS pool? First of all, we're not going to go into ZFS internals. This is, it can get down really deep, but we can talk about that at some other point if there's interest. So a ZFS object is something you allocate out of ZFS. Inside ZFS, like I said in LVM is more of a static allocation. Is anyone familiar with LVM and how it stores data with Disk Manager? Raise hands? No? Okay. So generally speaking, you statically define a range in your ZFS volume group, and when you do reads and writes, you update that range of storage. When you write to block 500, every time you write to block 500, you update that particular block in the storage. ZFS is different. Like I said, every time you write to block 100, a new block is allocated out of the pool and replaced into a Merkle tree that represents the object. Right? Sorry, the scrolling on my mouse is doing the wrong thing. So all this is the complicated stuff, complicated upfront sort of concepts we need to deal with. ZFS, like I said, represents objects as file systems or block devices, but they're not like LVM where they're allocated out of a range. They really just look like a hierarchy of blocks. Does anyone need any more information, any more about that? Or are we good?
So you're saying when they say pool, they're not kidding.
Correct. So it's just a storage, it's just a bunch of storage blocks. All right. And when you create an object, the top level, there's a top level hash. It contains a number of block references. When that object grows, it will split and get and become a tree until it can grow into ungodly sizes. All right, a small object, very few blocks, very few internal blocks. Terabyte objects can have multiple blocks. Now, a lot of people don't use this, but it was a selling point at one point with ZFS, where blocks could be reused in the form of dedupe. All right, because since an object is represented by a tree of blocks, there's no reason why you couldn't have the same block that's a duplicate in multiple entries in that tree. So you can dedupe. But nobody uses that anymore because it's very memory intensive and very inefficient. Okay, I'm going to go to the next slide unless anyone has. Deduplication being ZFS worst implementation feature. I get that. NetApp and Sun, sales elements. Yeah, this is all, we're all in Linux open source. So has everyone got this conceptual stuff down before we go to the next slide? Okay, next. Now, like I said, a ZFS system looks like a common Linux file system. So in here we can do mkdir test. Of course, I don't have that. Oh, it looks just like a file system. This is actually the top of the pool, which is kind of helpful because if you're used to LVM, you can't really do that, right? You have to allocate a volume, format it, and put a file system on it. Next thing is zvols. I touched upon them briefly, and a zvol is the block device. All right. It looks like a block device. You can allocate partitions out of it. You can even set if you put ZFS in your init RAMFS, you can even boot off a ZFS ZVol. And so you can use it as a LUN. Right. One of the cool things about ZFS that you really can't do with LVM that you can do with ZFS is you can allocate volumes sparsely, which means that if you can allocate a 2 terabyte volume, and it'll take up no initial space until it's used. So if I hyper, right? So I just created a 2 terabyte volume called Big ZVol. And my free space hasn't changed. That's because the ZVol's there. I can put a file system on it. So that's just creating a very big file system on a very, very empty LUN. If this were LVM, I probably wouldn't be able to do it because I don't actually have enough disk space to do it. But this will create a file system that looks like a 4 terabyte file system, acts like a 4 terabyte file system, and will sort of crash when you fill up your hard disk, when you fill up your space. All right. Now's the fun part. You remember we talked about how objects are basically represented by a tree. The interesting thing about the tree that they are represented by is that they are a loosely based tree, and they are linked by cryptographic hashes. Right? Anyone who wants to can do a search for Merkle tree on Wikipedia, but basically the hashes, the blocks themselves are loosely based. There's no reference-based pointer to blocks. There is a cryptographic hash reference to blocks. So an object is nothing more than a series of cryptographic hashes. All right, and links to cryptographic hashes, which means that every time you update a block, the cryptographic hash of the higher up block changes, and so forth. So now we have that. So we now have this mount temp that is 4 terabytes. Notice that it's bigger than the ZFS Z pool, and that's because it's allocated sparsely. The only space it takes up in the Z pool is what's actually been read. Everything else will just return zeros when you try to read it. And these are all various volumes. What's used, and where's Big ZVol? And Big ZVol here. We're only taking up 368 megabytes. All right, even though it reports itself to be 4 terabytes. Now here's the fun part. We're into got something. Let's DD something. We're gonna put random data on this. DD.
You have a blocking random.
I know. We have that. That's a nice piece of data. So what I did is just create a snapshot. A snapshot basically makes a duplicate reference to the top level of the Merkle tree. Now, notice, if you will, that even though I made a snapshot, not much space has changed. We didn't duplicate what was used. We only duplicated a reference to it. Now, if I go back into I have 2 blocks in there of random data. Now, if I were to here are the snapshots on my system, right? We see Big Z-Vol Ridge. It's using 346K, and it refers to a 37 megabyte volume. So what we have here now is we have the previous version of the disk that just has that one data set, whereas Z-Vol itself has 2 data sets. Now, they reference the same data, they share the data. The only difference is the live volume has the additional data. So we don't duplicate anything. We are just basically making a reference copy. All right. And the snapshot, like I said, is a read-only representation of a ZFS object. All right. It's just a copy of the Merkle tree. It's effectively a copy of the Merkle tree. It cannot be changed. It's read-only. It has the data. You can use it for long-term backups because it is so lightweight. It shares the blocks with the object that it's a snapshot of. And you can have thousands of snapshots. My previous company that got bought by Actifio, we used ZFS to basically maintain thousands of snapshots, point-in-time recoveries for years on end. Right? And ZFS is great in that when it reads data off the disk, it checksums the data that it reads and can test whether it's valid or not. Now, clone is an interesting thing. Now, say we just did something stupid. We deleted a file. We all like to do stupid things, right? Let's mount. Here's our data. It's all good in there. We just deleted an important file. Oh my God, I've been working on that for a week. All right, what do we do? Well, this is cool. Well, okay. Now, if I one has test data, right? So the snapshots are very lightweight. You could probably run a snapshot every hour on your computer. All right. And if you ever just delete something by accident, you could probably just get it back from a clone whenever you want. And to prove that, uh, 6A 1437. And here we go, 6A 1437. That's the file we deleted. It's there. We can copy it back to temp. We can even revert the data if we want, but that would lose subsequent changes. So a clone creates a usable volume from a snapshot, right? This volume is also read-write. Forgive my spelling. So the clone sits in front of the snapshot, and when it doesn't have anything in its own Merkle tree, all right, it defaults to the snapshot Merkle tree. And the snapshot Merkle tree defaults to the original object Merkle tree. So data is very sparsely used here. We're not duplicating a lot. If I were to copy test.data back to my original, I would probably end up making a duplicate copy because I don't have dedupe enabled. But that is what it is. Now, we've just gone through some of the basics, and the question is, how do you use that for anything useful? This is sort of like out of our Actifio playbook, but it's common knowledge. This slide is here for, is everyone familiar how to set up SSH with passwordless connectivity? This is a very quiet group. Nobody's asking questions. All right. So
We're using mute like good people.
Yeah, that's the way we access the BLU server. It's all through RSA keys and SSH.
Well, you should switch to elliptic curve, but
who said that?
Is there a reason that you didn't use the .zfs file system to access the previous snapshot?
Yes, because it's a ZVol. I had to do a clone. And these snapshots don't show up in the ZFS.
Oh, that's right. You made an X4FS on top of it.
Oh. So I have two VMs here. We had a pretty interesting discussion last week about how useful VMs were. So I actually love VMs. So of course, SSH, demo2, works. We have a shared key, all that. Beyond the scope of this particular meeting, but it's all set up. Now, we've done a little of this. We have zpool. I've got a zpool created. It's based on VDB. VDB is, that's the fun part. I'm using KVM on my Linux system to create two VMs, demo 1. And these are just basically files that I've put on my ZFS file system. And this is one of my favorite tricks where I just touch a file, truncate it to the size that I want, and put a file system on it. I'll put a VM on it. All right. So we have two VMs here, demo 1, demo 2. Let's go. And we're going, let's delete this demo. I have one of those days you just can't type.
Most days.
All right, so we have no pools. It's empty. Let's create one. There is a drive called VDB on this system. It was created just by using touch and truncate. Now, so this command here, zpool create, the A shift is interesting. ZFS, it might be different now than later versions, but older ZFS defaulted to a 512 byte block size. Even though some hard disks today still advertise a 512 byte block size, they're all 4K. Make the internal block size that we allocate 4K. Right. We have our pool. I think I've already got this directory open. It exists. We're going to create a file system that we're going to mount. Not a ZVol, a file system. All right. And we're going to use compression because why wouldn't you? All right, so now we have no. We set the mount point. Do that. You see that zpool devil is mounted on devil. Let's create the destination pool for fun. Do the same thing. Someone mentioned that you can see the snapshots in the hidden.cfs directory in each mount point. I'm not sure I was aware of that. It's actually pretty cool. But you can also list them with FT snapshots, and you can make them visible by default with a setting. And so now we're going to do the same thing on this side. So we only need to create the pool itself, because the pool is not going to be serving anything. We are going to be using it as a replication target. Let's create a snapshot of our pool. Now we're going to send this over to the ZFS. Oh, that's interesting. Yeah. Let's hope that doesn't break much. No, didn't, of course. We have now created our pool on the other side. Now this sounds kind of mundane, kind of sad, but it's very interesting what we can do now. We're going to do this nice new thing, make some data. Okay, so it's there, it's nice. Nothing's there. Now we're going to do the fun stuff. Now we create a separate snapshot. Two snapshots listed. I don't see a hidden .zfs directory. That might probably be a setting. So now we're going to send our snapshot over again. But the difference this time, if you'll notice, that we give the previous snapshot on the send command. So what this does is this does a diff between the two Merkle trees, the snapshot 1 Merkle tree and the snapshot 2 Merkle tree, and whatever's newer, whatever's not already there, will be sent. Right? We just sent basically the diffs between the previous snapshot and this new snapshot. So no matter how much data you have in this hard disk, the only thing that's going to be changed, the only thing that's going to be sent is the difference between the two snapshots. So you could have terabytes of data, and if you've only had 50 megabytes of change, you'll only send 50 megabytes over. And as you can see here, that's data. And if we do is the same. So it's a very, very simple thing, but what we've actually done is we've done an incremental backup and resulted with a full backup. Right? So there's no date, time, whatever. There are 2 snapshots on this side too. Right. So, and we could continue to do this every single hour, every single day, or whatever, for as long as you want. And the only overhead that you would have of the snapshot is the metadata that keeps track of the changed blocks. So this is a very efficient way to have a full backup done every night by only setting up the change blocks. There's no tarring, there's no tarring up your whole terabyte of Oracle data. You're only going to send the stuff that's changed since the 2 snapshots. And I'm not going to go into it in this, but if we want to keep snap 1 and snap 2 as constants, you would destroy the old snap 1, right? You would rename the new snap 2 to snap 1, and you do the same thing on the demo system, on the destination system. And that way you'd always be doing the diff between snap 1 and snap 2. But you don't have to do it that way. And this is a simple script that you could run every night that would just, in perpetuity, send your data to a replication server or a replication target, and you would have the equivalent of a full backup every night. And one of the cool things about ZFS, and I will say off the bat, there are a lot of things that I really dislike about ZFS. And having crawled around on the internals, I'm not entirely happy with how it's developed. There's in version 7, there was a lock inversion issue with Linux that you would occasionally hit once in a while. As far as to my knowledge, they haven't gotten rid of this problem. They've only guarded better against it because there's a slight difference between the way BSD does file operations and ZFS. So I have problems with ZFS in general, but I like the way it does everything on the user space level. I think it does everything you would want a volume manager to do. Right? So this simple script, send your snapshot, send your data, delete the oldest snapshot, rename the newest snapshot, and do the same thing on the target side. And you could do this every night and have a complete and full usable backup of your daily work and only send the change blocks. And that to me, I see a lot of people still doing, full tar, full whatever, and you can enable compression on these disks so you can save space.
Our snapshot does similar type of thing.
Our snapshot for Oracle, right?
For Linux,
What's our snapshot?
it's a Perl script that's included in most Linux systems for doing backups. It does snapshots, and it uses rsync to essentially send over only blocks that have changed.
All right. So the problem with rsync is that to know what blocks have changed, it has to go through all the blocks on both sides and compare the checksums of the blocks. And so it's faster. ZFS doesn't have to do that. ZFS has all the change blocks in its list. And so it's really much faster than rsync.
I would agree.
All right. There's also some change block drivers that you can use with LVM or Disk Manager. And they're good, but they're limited to LVM volumes. Right? And LVM snapshots are interesting. Disk Manager itself is a lot more capable than LVM, but I don't think many people dig as deeply into LVM as in Disk Manager as they could, and they're just satisfied to stay at the top level LVM system. So when you take a snapshot on LVM, what you're doing is you're creating basically a series of extents in your disk pool or your volume group, and I forget the size of it, but it pre-allocates a chunk, and then LVM snapshots are copy on write. So when you update a block in an LVM original, the data that was there previously is now copied to your snapshot. If you have multiple snapshots, every write to your original volume that changes a block, all right, gets pushed out to each and every snapshot. So LVM snapshots can be very expensive if you have multiple ones hanging around. And you can do something very similar to this on LVM by keeping one live snapshot each time. So you can do a snapshot in LVM, do another snapshot in LVM, and you can look if you the format of the snapshot is something that's knowable. It's in the kernel source, and it basically has a header and then all the blocks in a was-is sort of thing. And you can get the change blocks out of the LVM snapshots. But ZFS with the Merkle tree sort of has that already. And if you want to take a look, we can do.
How hard would it be to do the ZFS type backups using Amazon S3 storage as the remote backup server?
Okay, so it's a very interesting question. The problem is that the ZFS backup assumes that the receiver is a ZFS formatted system and can understand the snapshots. All right. You
Pretty
can
much
do it.
required. Yeah.
All right. So I'll show you a way to do it if you're interested, because if the humble developer wants to try this, this was one of my original prototypes that I did for Actifio way back a long time ago. So let's see. Right. Here we go. This is ZDB. ZDB is your friend. If you really want to explore ZFS, all right. Remember how I told you about a Merkle tree? This is basically dumping the Merkle tree. We have an L5 hash, L4, whatever, and this is all the hierarchy of the tree. L5 is on this, the highest. There's an L4, L3, L2, L1, and one block here and one block here. All right. And those then points to the L0 now points to these blocks in the pool. And this information, this is the offset into the object. These are the checksums. And I forget off the top of my head, but there's a way to convert this information
Live streaming is on.
Okay, so the question was, can we use ZFS to replicate to an S3 system? And the answer to that is yes, but it's not as easy as one would hope. So using ZDB, we can dump out the effective tree of a snapshot. And we can do that for each snapshot. And you'll see this snapshot has the same L5, L4, L3 hierarchy. It has a bunch of blocks allocated. Now, I don't remember off the top of my head how I did this, but in here there is a findable block. So you can write a small differ that can look at this information and do a diff and basically get that block out of ZFS and pass it up to S3. So if you were to do this, what I would say is I would create not a file system, but a block device like a ZVol, all right, and use ZDB and snapshots to send the changed blocks for that block device to S3, the S3 bucket. That's just off the top of my head. I mean, it's something we'd have to figure out, but you can find the blocks in a ZVol that have been modified between two snapshots. You can extract the data from the snapshot you want, and you could write that to the S3 bucket. The implementation is up to the humble reader. All right. So I didn't want to get too much into the internals. I mean, it's always fun to go down that road, but this is really about backing up and forever. So, like I said, snapshots are really, really lightweight. A snapshot of whatever volume is only really taking up 1, 2, 3, actually, and some of these are shared. If this block will be shared, so if you see it, it's A033 whatever. I don't know. Blocks will be shared. The snapshots only take up space on the changed blocks. So you can have as many snapshots as you want. You could do a snapshot every hour, and then just save a day's worth of snapshot, delete the old ones. You could do a snapshot every month, every year, every quarter, and keep them around. And as long as your replication target is secure, you have a good long backup that's easy to use, very secure. ZFS checksums and checks every single block that it reads. Unlike RAID, where you can have silent corruption or RAID and not even know. How many people have an MP3 collection that suddenly skips after a while because there was a block that changed? Well, in ZFS, that block would be detected and you'd see a checksum error, and you'd know that happened. And a lot of people used Actifio software as long-term storage for corporate governance, right? So they could go back to a particular point in time and say, yes, we know we backed this up on the day before that operation, and this was the state of what we had. So you can keep that around. Like I said, they only retain changed blocks. You can have thousands of these, and in my company we've tested tens of thousands of snapshots in a pool, and the snapshots themselves don't seem to impact performance. But if you had a clone for every snapshot, that would kind of swamp UDIV at boot time trying to instantiate all those zvols at startup. If you have, you'd have thousands of block devices, and no one would want that. Right? They're good. Snapshots aren't just for backup. They're good for, like I said, disaster recovery. They can be used for clones. You could create. So, for instance, say you have a very, very large Oracle database, a terabyte of data, and you want to use that for test and dev. You can take a snapshot of your Oracle data, clone it, and now you have a full copy of your huge Oracle database that you can spin up a new Oracle instance and access. All right, because it's just a clone. It's you're using a snapshot that's lightweight, and you're using a clone, and the point in time that you took that snapshot is the database that you can use for test and dev. You can create a series of VMs. Say you need 100 VMs that all do the same thing, right? You can make one VM snapshot and clone it 100 times, and then when you're done, just delete all the clones. And so this is an example. You want action recovery. You can take a snapshot every 15 minutes, right, on a cron job. And of course, you might want to write a script or something to clean up after overnight and all that kind of stuff. And you'd never lose more than 15 minutes worth of data. You'd always be able to get it back. As long as it's saved, you're good. All right. And you wouldn't see much effect on performance at all. Like I said, you can use it as a historical archive. You can do it once a week, once a month, whatever is important. If you're a law office, you might want to take a snapshot and give something for discovery or whatever it's there. You can do it by release dates. You can do it by anything that's important to you. And of course, you can replicate. This is what I was talking about earlier. If you took 100, if you want to make 100 VM instances, you could install one, get it the way you like, take a snapshot, and clone it 100 times. It's not updatable because you're not updating the snapshots. The snapshots are immutable, but it can save a lot of time if you want something quick and early. For all the people yawning out there, I'm almost done. You can do a larger scale backup. As you saw in the demo, we were able to easily replicate the snapshots only by change blocks. Well, if everyone on their laptop had a ZVol, a ZFS implementation, and their home directories were /laptop 1A or 1B, you could use this replication strategy to replicate every single laptop every night. And it would only be the changes. And that's it. Done. Open for questions.
Thank you. I think it's an excellent presentation.
All right. Any questions? Any really deep questions that anyone's curious about?
Is it fairly simple to set up a set of ZFS on a laptop?
Yeah. Well, what version of Linux are you using?
Fedora. That's what's the latest, 35 or 36?
That's interesting. Does Fedora have ZFS internally? I know Ubuntu does.
I'm not really sure.
Right. But it's easy to set it up if it's part of the operating system. I mean, I don't know how hackerish you guys still are. I have lost my patience for doing a lot of this stuff outside of work. So Ubuntu just comes with it, and it puts the ZFS modules in the init RAMFS, So you can use ZFS as your boot, your home volumes, or root volume.
Jabber, you might want to investigate ButterFS and do similar things with that,
Yeah,
since Fedora comes with ButterFS.
is it? I know they took it out of Red Hat Enterprise.
Yes, they did.
How does that bode for Fedora? Is Fedora's sort of like test and try to get it to prove itself, or do we think that it's going to go the way of Riser FS?
Well, yeah, but Hans killed his wife.
I know, and Larry Ellison killed son. So,
Well, that's true too.
no,
I don't know. I think it does not bode well for the future of ButterFS.
Yeah.
But I mean, you need a modern system.
Yeah.
You know, ext4 is a decent file system, but ZFS is a better enterprise class system than AXT4. And I don't know if ButterFS is ready for enterprise yet, or ever will be.
Having been in the enterprise space now for about a decade, I'm not impressed with things that claim to be enterprise ready.
Yep.
But like I said, I've been working with ZFS for a while, and it's what I trust. I have really come to trust it. We were I can't give you specifics because it's under embargo, but ZFS can find things that a lot of other systems just can't. All right. For instance, there was I don't know, about 5 years ago, a major hard drive manufacturer had a firmware bug, all right, in their systems where, under the right circumstances, the last 12 bytes of a write would be lost. All right. We found it with our product using ZFS and our dedupe system. Like I said, we were under embargo. We can't talk about it, but suffice to say, the industry got firmware updates after they figured out what it was. After we said, "Why are we getting checksum errors? Why are our pools getting corrupted?" All right, and you don't see that with regular RAID. You know, regular RAID just reads. It says, "Okay, here it is," but ZFS reads, checks the checksum, and says, "Oh, this isn't right." And so, if you care about your data, I won't say that ZFS is the fastest file system out there, but I would say it's the most secure. And believe me, I'm not trying to sell ZFS. I hate the internals.
I just took a quick look at Fedora, and it's not on the Fedora distribution.
Yeah.
So you have to add it.
You will probably have to go to zfsonlinux.org.
Yep.
Download it. You may need to build it. Then if you want to boot off it, you'll need to use something like Drake-it to recalculate your init RAMFS to put the drivers and make the drivers available at boot time. All right. So I'm going to stop sharing unless anyone else has anything else.
No, thank you very much.
Yeah, thanks, Mark.
I really liked it.
Oh, thank you. And if there's interest, I can do an internals walkthrough at some point.
Yeah, Mark, send me a copy of the slides so I can post on the Blue Web server.
Yeah, I have a PDF I can mail you.
Okay, that'd be great. Thanks.
All right. So what do I do now?
So I guess we're pretty much done. Unless people want to talk about other things.
No, I'm gonna go have dinner with my wife.
Okay.
All right. Catch y'all later. It was fun.
See you. Thanks, Mark.
Yeah. I think if I wanted to set up an infrastructure with ZFS, the easiest thing to do would be start by switching to Ubuntu.
Do that.
Unless you insist on ZFS on root, Debian is quite as easy as Ubuntu, with the exception of one more command: apt install ZFS.
I call it a night now. So Jerry, you can turn off the live stream at this point.